Hello there. Welcome to the stream. I don't know, sometimes I like to be silly. So, today is going to be a little bit of a short stream. Sometimes life stuff happens, but I always want to try to be on at the same time every day. So, what I wanted to do today was do something that was a little bit visual. And so, to that end, I thought it'd be cool to look at sort of different visualizations of different properties of the planet all across the planet. So, for example, we can look at different things, ways to look at air pressure, at elevation, at humidity, all this stuff, and have like cool colors to help us see that stuff in different sort of what you would call like ISO lines that kind of move and flow around. So that's what we're gonna try to look at here today. So to get started, the first thing is, let me show you kind of an example of what I'm talking about that I just kind of stubbed in really quickly, but I want to do it in a little bit more proper way and add more types of things to look at. So if I go to, I have this thing that's called a shader that outputs the color for every pixel for the planet, and right now everything's kind of covered in ice, so it's kind of a white color, but I have this thing that I call debug output, and when I enable that, what it's going to show me is, if you look at this code here, I'm looking at the air pressure, and then I'm getting its difference from the average, and then based on whether it's above or below average, I'm making it either a red color or a blue color, and then this cell shade here thing just kind of divides it into like chunks. Instead of having like a smooth gradient, you'll see it look more like, say, an elevation map. So if I save that change to enable that, you'll see right here that I've got a little bit of that going on. It does look pretty smooth, but that's because the changes are pretty small. If I zoom in, you can see there's a little bit more gradation. And if I were to do something like apply some heat, then you should see, more lines going on, and the pressure you can see is flowing from the regions of high pressure to the regions of low pressure. And so that's one example. I've got, if you look at this other tool I have that just shows you values in the corner of the screen, I've got wind velocity, like the total water mass, relative humidity, air pressure, surface temperature, all this different stuff. So like I can look at this, move the mouse around and see in the corner the surface temperature in different areas. You can see it's a little warmer in the northern hemisphere, about 235, 240 Kelvin, because the sun's in the northern hemisphere right now, and then just a little bit cooler in the southern hemisphere. So with that, what I want to do is kind of make it easier to switch between these different visualizations, and so I can just do a drop down and bam, look at this, bam, look at that. And to do that, what I'm going to do is, on the planet, it has sort of it's the thing that kind of controls rendering a little bit, and so I'm going to give it a drop down of all these different properties, and then I'm going to pass that through to the shader, and then that shader will sort of do different things based on that value it receives. So with that in mind, let's get to it. So I have the script planet, and what I'm going to do is go to the top, and the top is where you kind of define a lot of these things, these variables that appear in this editor right here. For example, you can see I have a checkbox called run simulation, and if I look for that here, except that's not the right script, better example, terrain renderer. Okay, so I have a terrain renderer. So I have this, what's called a public variable, meaning that it's sort of like visible to the outside world, of this type, which is a mesh renderer called terrain renderer. And so you can see that appears right there, and I can like assign different things to it. And so I'm going to create a new thing, and I'm going to call that, I'm going to make what's called an enum, which is short for enumeration, which is just sort of like a list of different, or a set of different values that you can choose among. So I'm going to make it called visualization type, and I'm going to have like default or normal. Let's go with default. And then if I looked at, as an example, my camera had that surface properties display script, so I might just use the same thing here, and just instead of writing it from scratch, just reuse the same thing, and that's so I can do like instead of defining an enum here, I can just say that I'm going to reuse that type. And I'm going to call it visualization. And I'm going to say default. I'm going to add that just so we can not be one of these special things if we don't want to. And then I have to add a case down here to make sure I handle that correctly, because I have this thing that says like if I don't know what the thing you're trying to display is, then I'm going to throw an error. So I'm just going to quickly add a case for that to that script. And then I'm going to go back to my planet, which is what I really care about. And so I've got this visualization. And then it's got an update function. And what I'm going to do in the update is set some materials on some parameters on the terrain renderer. Actually, a better spot might be right here, set shader parameters that I already have. Yeah. So I'm going to go to the material I use on that terrain renderer, and I'm just going to set an int. Int means integer, which is basically a whole number, so there's no fractional part. And I'm going to call it visualization. Actually, an easier way to handle that instead of this is the easiest way. So I'm going to treat that enum as an integer, because under the hood everything in a computer is a number. So that's going to pass it over to the shader, except now the shader needs to actually do something with it. So I'm going to go to that guy, and I'm going to put this variable in here somewhere. And go down to the bottom of the function, which is where like sort of the entry point to my shader is. And what I'm going to do is say is if visualization is 0, which is the first thing in that list that I had, right? If I go to this, it's 0, 1, 2, 3, 4, and so on. Then I'm just going to do the normal thing. And then I'm just gonna do what's called a little thing here that's sort of just an optimization. I won't go too deep into what that means, but just hopefully allows the GPU to like not execute all the instructions for all the if else stuff, because normally a GPU would probably just sort of execute all the different possibilities and then pick one at the end, and so it's a little bit expensive in terms of computer processing power, but this allows it to say, no, I'm actually just going to do this one and not the others. So if visualization equals 1, I'm going to look at elevation. That's elevation, so I'm just going to write that there as a sort of note. And what I want to do is kind of make most stuff zeros. So I'm going to make pull this into a function called like clear output. Just to avoid rewriting the same code a bunch of times. So that just means that like everything else is gonna be kind of default zeros, like it should be basically a black color until I do whatever comes next. And so I'm gonna do a display elevation. I'm just gonna call it that. And what is it? Oh, it's the output. And so I'm just making a little function here to make it a little cleaner. And with that in mind, we're gonna kind of do this at the beginning of all of them, is just clear the output to be basically a black color. And then what I want to do is something kind of like what I've already got here. I've already kind of wrote some code that I can delete from that part and just kind of move down here. And so what this is saying is, given the height, and I hard coded like an average value of 500, but what I really want to do is pump in an average, kind of like I did for this other one where I have an average air pressure. So I'm going to add also land elevation. I don't know if I want to do just the land or include the water. I guess for now I'll do just the land. So I'm going to replace that. And so that means I need the CPU to actually send that data over. This actually can come from the simulator. That's where I'm kind of getting those values from. I have this script called simulator. Data 0. So that's just some data. Basically, I tell the graphic, it's kind of a back and forth thing where I tell the graphics card, hey, compute the average for all the points on this sphere, all the vertices, and then I get it back here on the CPU, and then I'm sending it back to the GPU in a different shader. And so I get that. Not that one. So I'll double check. Yeah, okay. And I'm gonna call it height above sea level, and I'm gonna just sort of make it a relative percentage by dividing by the average, so that it hopefully kind of works in most circumstances. Do I want to do that? Actually, maybe not, because then it'll kind of, as I'm making changes, it'll shift everything else. So I'm just gonna pick like a value, so like 100 meters is every sort of gradation. So if we take a look at that, I made some kind of error, so I'll just quickly fix that. Oh, I have that twice for some reason. So I just have to make sure I pipe through all the right data. Fix my typo, and bam. Cool. Not sure why that happened. Let me restart the simulation here. Oh, because I edited the code while the game is running, and Unity just doesn't generally like that. Okay. So I've got my planet is rendering normally. If I go to the planet, then there should be a visualization default, and if I pick elevation, yeah, it's gonna get purple where it's higher. And let me turn off the clouds just so we can see that a little more clearly, that yeah, it's got those nice gradations, and so I can easily tell like where I'm raising the land, where I'm lowering it, and the white is kind of just in the middle. And you can tell, if you have ever looked at like a elevation or topography map, you know, in the real world, you'll see these kinds of lines, and the closer together the lines are, the more, like even on Google Maps, the closer together they are, the steeper the surface is, and so you can see that happening there. So that's pretty cool. I like the way that looks. It gives it this like weird cartoony kind of look. So that's just one of them. We've got a bunch of other things that we can look at, but I could do more than that. I could even go and look at examples of like elevation maps. They might have different colors they use, like not just two. So let's try to use that as sort of an example, one that looks kind of nice. Let's just go to Google Maps. And if we go to, let's say, Seattle, 1A, and then where do I do the thing? I used to know how satellite. I don't want satellite. I want. How do I get the other things? Maybe here. Terrain. There we go. Okay, so we can look at the terrain. And this one just seems to be making it green, where it's a higher elevation, or maybe like where it's supposed to be greeny green. I think if you zoom in, yeah, you will get the lines, but it just has numbers on them, not the actual like different shades. So I take that back. So let's just go back to an image search, and let's see. What do you think? Is there anything that's gonna stand out as like, oh, that's a nice looking one? Kind of like this one here. So this one at ground level is kind of greenish, and then it goes to yellow and more of a red color. And so we could do that, and we can make it maybe blue below the sea, like we already have. So what I can do is just do a kind of bunch of if-elses. And so if I do every, let's say 50 meters, so the first 50 times 10 is 500 meters will go between, actually let's do this, let's do the kind of in ascending order. So first, if it's less than 0, I'm going to do the blue, else if it's less than, say, 500, then it will go from white to I guess I wanted that green, didn't I? So let's make it a green, but like not such a bright green. Wait, I did that backwards. So that's, you want that one to be blue and this one to be green. And then this one will go from green to more of a yellowish color according to the map. So let's make that like something like a little bit of red, a little bit of green together makes yellow. And I have to change these values here, so basically height above sea level minus 500. If it's less than, let's say, 1,000 is the next thing to go from yellow to red. Or I guess I can, at that point, we're just at our top of our game, so we don't need to put like a maximum there. And it's going to go from that yellow color to a nice red. So let's see if that worked as expected. So where it's deep, it's blue, and then we around sea level, it's green, and then goes to yellow, and then more of a purple color. I make it really high. I don't know why it's being so purple. Oh, because I have a little bit of blue in there. Or a lot of blue in there. Look. So now we have that. So now you can get a kind of really good look at what your terrain really looks like. And so yeah, that's so we got our elevation going good there. So awesome. So let's see what's next on the list. Planets. What am I looking at? Not that one. Planets. What did I call the display property? Something or other. Visualization. So the next value is surface temperature. Okay. So we're gonna make a thing called display surface temperature, kind of in the same vein. I'm gonna make it have the same parameters. And this comment here is kind of unnecessary now that it says elevation right there. We're going to do a similar thing, so I'm going to go ahead and use that as sort of like a template to start with. And so instead of X, which contained our elevation, Y contains our surface temperature. But now what I want to do is, it's not height above sea level, it's just temperature. And I'm going to just kind of, instead of using an average thing, I'm just going to say, you know what? On Earth, we expect temperatures to be in a certain sort of range, so let's look at that. So if temp, I'll call it surf temp, or just temp, temperature. So if it's less than 273, which is in Kelvin, 273 is 0 degrees Celsius, which is the freezing point, then we'll make it, do we want to make it blue or white? Let's make it white. But we'll go from blue to white. So, and we're gonna do an increments of like 50 maybe. Okay, so we want to go from blue to white, except I want that backwards, so like as it goes warmer it goes to blue, and so the white is supposed to kind of look like ice. If we did it in increments of 50, and we have, let's say, well actually I do kind of want to do it backwards. Because I want it to be even increments starting at that 273, and then at the very bottom, if it's like a thinner sliver, it's okay because we're going to absolute zero. It's sort of like a extreme condition. So if we go from blue to white as the temperature drops down, then I think that should work. And we want 6 of those, because 6 times 50 is 300, which is just a little bit more than that. Or if it's less than, let's say we want to know if it's in like nice livable range. Or let's say let's go to like really hot is like maybe 40 degrees Celsius, which would be 313. And we're going to go from that blue to like a yellow color. So we're going to subtract out that 313, and we're going to do that in increments of 10 only. And then finally we're going to do the really hot range. It goes from yellow to red. And we're going to make this go over a much larger range because there's kind of no upper limit to how hot something can get. So to that end, we're going to do in increments of like 50, yeah, I guess 50. But we're going to go with like 20 gradations. And I used the wrong variable there because of my stupid copy and paste error. But all is not lost. Okay, so we're looking at what we were looking at before. I have to go to the planet and change it from elevation. Didn't I play with elevation more than that? Okay, so that's elevation. Which looks pretty nifty. It has this sort of like Tron kind of look to it, to surface temperature. And you can see everything is kind of a little bit cool in that blue range. If I actually use my little mouse thingy to look at the actual numbers, I can see that it's 240, so it's a little bit below freezing. But if I were to go and say make the sun a little bit hotter, then we might get something else, maybe, if it does enough. And I was just barely pushing that into the yellow range. I can also just go and manually throw in some heat. And that's kind of what that looks like. And you can, from a distance, it looks pretty smooth, but when I get closer, you can see those gradations. And this because I'm throwing such an extreme amount of heat in there. If I throw less heat in there, you can see those gradations a lot better. And it's pretty cool to see it kind of warp around. Cool. So I'm okay with it, except the yellow to blue transition's a little bit harsh. I kind of wish I had something more mellow in between, like a green. So I'm going to go ahead and do that. So let's make just something halfway in between. And we're going to make it in increments of 5 degrees. And we want 4 of them, yep. Same thing here. Now this is going to be increments of 5. And I did this backwards. So I had a little bug here, I'm glad I found it. But I should be subtracting out the previous thing. And I need to switch up my colors here. You go from, so this is now going to be a green color. And that's going to be the yellow, right? So cool, that makes, I think, for a better sort of gradient. And okay, so that's surface temperature. What else do we have? Surface water mass. So that's basically like either the amount of water in the ocean or the amount of water that's sort of absorbed into the land. So similar kind of thing. The water mass is here, and I'm just going to replace that to avoid any copy and paste errors with, let's call it water. And how do I want to do that? I think I want to go from like black if there's nothing, and then like the first little bit I'll make it white because there could be a little bit of water in the land, and then as it gets deeper it just goes to like darker and darker blues, and I think that'll be pretty good. So what did I do here? I lost my spot. I don't know why the making changes isn't finding my spot. Okay, display surface water mass. So if water is less than, let's say 1, and then we're gonna go from a black color to a white color based on the amount of water, and we're going to do every 0.2, and we'll do 5 of those. Okay, and then if we want just like shallow seas, maybe we show like a turquoise color. So we're going to go from that white, and we'll say like the first 10. A turquoise would have some blue, and it would have some green, but a little more blue. So let's make that like 6.5. And water -1 increments of, let's say, 1.5, and there's 6 of them, so that goes up to that 9. And that'll be a turquoise, and then from the turquoise, we want to go to like a rich full blue, which will just be like 001. And that's if it's less than, let's say, 100. Or minus 10. And let's say we have 9 increments of 10. Get us to that 100. And then finally, it's really deep. It's greater than 100, and every increment of 50, and we'll have 20 of those. And so we'll go from that full blue, but kind of a bright blue, to just a darker blue. And let's see if that works like expected. So I've got my planet here, and I'm going to look at surface water mass. And it's all black for some reason. So let's take a look here. If I do this, I should get like a really whitish color everywhere if there's any water. And so something's not going right. So let me take a quick look at the actual numbers. I have a lot of surface water, so maybe I'm looking at the wrong thing, wrong value. Okay, it's supposed to be this one. So that was confusing me a little bit. Maybe those values somehow just aren't getting passed into this, or maybe I'm not even hooking this up yet. That's why I have to actually run the code, don't I? So now it should just be all white because I'm displaying that water number, which is greater than 1 pretty much everywhere. Okay, so now I'm getting that some medium blues, and if I go and like shrink the land down, it should get deeper and darker than it is. If I raise the land up, eventually the water should just sort of pour off it, and I should get to that black, or in between the black and the white. Yeah, so if I go back to looking at it normally, you should see a mountain, and where the black is like fully above the water. The white's kind of a transition area. The turquoise is like shallower waters, and then it goes to the darker and darker blues. Let me turn off the... Yeah, so that green grassy mound there is above the ice, actually. So right now my planet is frozen. It's too damn cold. So that's cool. So we got that, and then the next is the air temperature. So it's going to be the same thing we do with the surface temperature, except just with a different value. So what I'm going to do is actually kind of pull this code out into like a common thing and reuse it. Display air temperature. That way, if I ever decide to change it, I only have to change it in one place, and it'll apply to both the air and the land. Display temperature. Let me just copy that really quickly. This one, the only thing that's different this one is I'm going to tell it which it's going to assume it's already got a temperature coming in, and I can get rid of that. And so then I just send in a different temperature in either case. And just to make it one nice clean line. This is going to be air properties 1.x, I believe. Just double checking. I can see right here that I did a quick search in my code and I found for the air, yes, the first thing, which is, so it goes X, Y, Z, W. The first thing is in fact the temperature. So now I just need to use that thing. And the air should be cooler, probably, although the land temperature should change, I think a little quicker, if I remember correctly. So let's go to our, just make sure I didn't mess up the surface temperature stuff. If I throw some heat, yeah, it's getting hot. And actually, you can kind of see the depth shift there too, because it's basically boiling the sea. And this reminds me of that one like addicting video game that had it in Star Trek The Next Generation that everybody went crazy over and started warping their minds. Just the way it looks. And now I want to look at the air temperature. You see it has a little bit more of a delayed effect because it has to affect the land before it can affect the air, and then the air will diffuse around a lot more, and that looks pretty trippy. I kind of like that. So I'm gonna. That's pretty gifable, to be honest. So I'm gonna go ahead and record a quick little video there. I liked it better the first time. Let me go to the other side of the planet and kind of start fresh. Still not as good. I'll go back to that later. Okay. So we're like halfway through those visualizations. Let's see what else we got. And so we got the amount of water in the air. So let's go ahead and do that. How do I want to display that? I think it's just gonna, maybe it'll go from like black to like green to blue to white. Why not? Equals, let me move this down to be in order. In dot air properties 1.y. So if water is less than, so here's the thing, it's actually pretty low numbers most of the time. Let me take a look at what a normal kind of number would be. 0.000 something. 0.00. How many O's was that? 3? So let's say if it's less than only 2 O's, then it's going to go from black to a green color. It's going to be basically water, increments of 0.0001. Going to be 10 such increments. And then if water is less than, I'm just going to go in powers of 10 here. Just going to go from that green color to a blue color. Nice. And I'm going to do increments of 0.001. I think it'll be 9 of those. And we're just going to kind of do that one more time. Maybe 2 more times. I'm going to go from that blue to a white. And then when it gets really crazy, maybe we go to a red. At this point, we don't really need an if. Okay, let's see what that looks like. Here's my little drop down. It's really dark. Oh, did I do it yet? Yeah. Oh, but I put the wrong number. Cool. So that should be because it went from black to green in the range that we have. Now if I go ahead and boil some water, we'll see it get really high. Poof. So that went to blue and then to white, and if I keep going, you'll get that red coming out. So there's a lot of water in the air right there. And then this is one of the cool ones. This is one that's really important for the work I'm doing next, which is I need to get winds going, because that's really the key part of all weather, and that is based on air pressure differences. So that'll be the next one to do. Air pressure. Instead of calling it like specific things, I'm just going to call it val for value. And this one's a little tricky because you have to add a couple things together to get the total air pressure. Because you get the water plus like the oxygen and stuff, and even smoke. So I'm going to add those in. Okay, so that looks good. And I know that normal, I do have an average pressure, so I'm gonna base it on that. I'm just gonna do copy this code here actually. Because I already had a way to display that stuff. Now let's just go here, look at the air pressure, and bam. And if funny thing, what might be a little counterintuitive is that actually when you heat the air up, it creates lower pressure. So if I add some heat, it should eventually turn into a lower pressure area like that. And you can see everything shifting around. It looks pretty smooth, but if I zoom in, you can see those gradations. And if things were to level out a little faster, you would see those get wider. In the meantime, what is next? Air gases is a very similar thing. It's basically the air pressure if you subtract out the water and the smoke. So I have to do a lot of environmental simulation to get all this to work. So hopefully you can get some really cool emergent stuff like hurricanes and all kinds of stuff. That's my hope here. And we're using this average air pressure as the sort of basis value, even though that also includes the water. But if we looked at how much water, usually it was pretty low, so it should make negligible difference. So let's just verify that assumption. If you go look at air gases, then yeah, we get basically the same thing. But if I were to start boiling a bunch of water, then we would typically see a difference, except I forgot to subtract out that water, so it was exactly the same. Just fix that bug there, and then bam. So looking at gases and looking at pressure, see that central circle had a lot of water creating all that pressure, but not so much for the gases. Those didn't really increase. So you can see some really cool phenomena happen when you just look at the values all at once like this. And if you're just joining the stream, basically what I'm doing is I'm creating different visualizations for all the different physical properties. Like I can look at the elevation of the land, so that if I raise it up a little bit, you can see sort of like it looks like a topography map. We get these sort of lines of equal elevation, and we make it paint a little faster. So you can see I'm creating mountains and they appear red, and middle elevations are kind of like a yellow, and then I can make it deep and blue, and you get these cool lines of like equal height. And so I'm taking that idea and I'm applying it to a bunch of stuff, all like a lot of different physical properties that I have. Like here's the surface temperature. You can see it's kind of warm there, but it's cooling off to match everything else. If I were to go and throw a little heat in there, then you would see that, and then it should kind of disperse around. It looks pretty smooth. If I zoom in, you can see I have some gradations there. And also I have stuff like how much water is on the surface. You know, this is black, meaning no water because it's above the water. And so I have different colors to indicate different amounts of water. Air temperature is kind of similar to the land temperature. Air pressure, as we were just looking at. And I'm going down this list, and I've got 4 more to do. I'm not sure how I'm going to do that last one, except maybe the overall magnitude of the wind and not the direction, but maybe there's a way I can put some arrows in there or something. Or I guess I could just visualize it as the red is in the horizontal X direction, like the going around the equator, and then the Y is north-south. But let's do the humidity. Summary display, and this one is surface relative humidity, which is important for weather, so I can get it to rain and have storms and all kinds of stuff. And then I'm just gonna quickly look up somewhere else where I already did the relative humidity calculation. So basically it's the amount of water in the air divided by what's called the vapor pressure. And so I'm gonna just copy this code over here. Equals in that surface property. I have all these different properties, 16 of them to be exact. Probably add more in the future. And the elevation is one of them. And temp equals in that surface properties one. I just have these memorized. What is stuffed in where? And then the humidity, and then the air water, the amount of water mass actually evaporated into the air. And what I'm gonna do is, it's gonna be white around 1, and then it'll go blue above that, and it'll go like black, or you know what? Maybe green and then red. Because like if you look at like rain, like Doppler images, let's see what those look like. Yeah, so where there's nothing. They're kind of transparent, it looks like, and then they go to like a gentle blue and a dark blue and a green and a yellow and a red. That's a lot. I think I'll just do black to blue to green to red, and yellow hopefully just comes out in between the green and the red a little bit. Okay, so don't need this stuff. So I'm just gonna call it val for value, so I can. So if it's less than 1, it's gonna go from all the zeros in the red, green, and blue, which is black, to like a blue color. But I'm not gonna make it a pure blue. I'll make it a little brighter than that, and I'm going to do it in increments of 0.1, and there'll be 10 increments. Val is less than, let's say, 1.2. Like, we don't have to go that high. Like, relative humidity under most normal conditions shouldn't really go really much above 1 at all. Otherwise it's going to be raining really fast. So we're gonna, it's actually, yeah, sure, whatever. Let's make it 1.05, even less. And we're gonna go from that blue to a green, kind of like you see in the maps. And we're gonna do maybe like 5 shades of 0.01. And then we're going to go to the red. So I don't really need an if here. I'm going to go from that green color to a red color. And since under extreme conditions it can get really high, we're going to give it a little larger range. And we're going to give it like 20 of those. I need to plug in the use of this. Oh, I gotta include a physics, like a extra code that I wrote somewhere else. So you can see it's kind of really dry air there. It's getting kind of rainy over there. And what'll happen is if I heat up the land a lot, you'll see a lot of water thrown into the land. It looks like it's never really getting into that red range too much. On this side, did I do my colors wrong? No. So I could even probably change that a little more to get some actual red in there. I'm curious what it looks like if I start my planet from scratch when it's like several thousand degrees on the surface. What it looks like. And right now everything's like so hot, nothing can condense. It's all boiling, and then it'll cool, and eventually you should see it rain. And there we go, and we're getting some heavy rains going on, but never actually above that. More than 5% above the rain point. So I'm going to change these values a little bit here. And I'm going to do it in a little bit smaller increments, and minus 0.01 and increments of 0.01. Throw some heat on there, boil some water. I have like a thin band of green. And yeah, we're never really getting super high, which I guess is good if it's, doing its job. You shouldn't really get above the saturation point too much. So then we're gonna see what else there is to look at. Not a whole lot left, just a couple of them. Air relative humidity is the same thing. Total water mass will apply similar to the surface water mass. And then the velocity will be a little bit interesting. So I'm really actually what I'm going to do is make a function called display relative humidity, and it'll be for either land or water, and I can pump in either value. Display I'm going to just take all this stuff out of there and put it in here. And I guess I did need the input values. Actually, not really. I'm going to take some of this stuff, not all of it. Oh, relative. Then I'm just going to make a slightly different one for the air. And of course, this is all the air, but one is like right at ground level and the other is higher up in the atmosphere. And that should be what we do. That's how we do. So let me just double check real quickly that I didn't do anything stupid and crazy. But it seems okay. And I need to call this relative. Just to have my names match. Well, So we got this band that seems to kind of be following the rotation of the sun, which kind of makes sense. You know, as it cools into night, often the relative humidity will increase and you can get some rains. Hello. Thanks for... Is this a galaxy simulator or a game? So the idea is... Sorry that I just saw it now. I'm having some trouble with my side screen here. It's a game where we have what I call a pet planet. And so it's focused just on this one planet. And it'll have all kinds of crazy simulations. And you can actually go and you can... like terraform it. You can, for example... I'm going to raise the land up here. And you can play with it if you want, and then you can just let it sit and let it, let's see what happens with the simulation, produces. And the idea is that you'll have a lot of crazy, unexpected stuff that you'll never expect, and you'll see your planet evolve through different phases. If I hit start from the beginning here, I'm kind of sped up time, and it starts in a really hot primordial state. The surface is basically like molten. And then over time it cools, and all the hot water vapor that was in the air cools and condenses, and eventually get rain, and oceans will form, and maybe life develops on your planet. And so it's meant to be a thing that you can kind of play with it as little or as much as you want, and just let it sit on your desktop and check in every now and then to see how things have developed. And that's basically kind of what the game is. And the planet will might respond to different things, and maybe have different events come from outer space, like meteors hitting your planet and stuff, and volcanoes rising up, and yeah, that's kind of the basic idea. And here I'm just throwing down some lava, just for the fun of it. Let it flow into the ocean, melt that ice. So I have just a couple more visualizations to do here. I think 2 more, right? Because I have the surface humidity, and then I have the air humidity, and then total water mass and wind velocity. The wind will be an interesting one. I'm not exactly sure what I want to do with that. But I have a thing already to display the air water mass, so I'm just going to borrow that. And I'm going to do this. I'm going to make a function called just display water mass, whatever type. And I'm going to have it where I can pass it in the water. And reuse that code for both cases. Oops, I did that a little bit wrong. So yeah, if you have any other questions, let me know. I'd love to answer them. I don't think I really need the in here. I do have an air water mass. Okay. So I had a little typo there. I'm just gonna fix really quickly. total is just the sum of the two, so that's really easy. This is air. So I'm gonna have amount of water in the air. There's a lot of water in the air in certain spots. Oh, I just realized I did mess that up because the air was different. So I'm gonna go back and see what I had before. Yeah, so these are I'm gonna copy that to Notepad really quickly. I had something different for like the amount of water in the ocean, because there's so much more water in the ocean than there is in the air, obviously. What did I just do? Air water mass, surface water mass. Okay. So I'm gonna have a display total water mass. And I do want to actually, this is going to be total. We use the same basic code as the surface one because there should be very little difference in the amount of water between the two. Display water mass. And I need to have the output, obviously, in the water. So I don't worry about that. It's coming in. Hey dude, do I have any life in there? Sort of some life. I do have some green stuff that can pop up if the temperatures and are just right and everything, but it's really super basic right now and needs to get more complicated. Basically, what I have right now is as simple as at every pixel, like I say, is the temperature of the air and the land between a certain amount, and is there a certain amount of water that would support life, and if so, then like increase sort of the life value of that point a bit, and then you'll see some green popping in. So obviously that needs to get a lot more complicated, but that's what I have right now. So what I'm working on right now is different visualizations of the different surface and atmospheric properties. So yeah, I'm almost done with that, and I'll show you this one and then all the others in a quick rundown very shortly. So this was just obviously the sum of the two, the land and water in and on the land and the water in the air. Also, if you looked at pseudo color palettes for these visualization layers, I'll take a look at that link later. Yeah, the simulation is all in a compute shader, yeah. Right now the visualization is just in the pixel shader. But that way I can simulate just a crap ton of points. Right now I have about 40,000 points around the surface of the sphere, which actually I want to go higher. But for some reason when I went higher, I was getting some weird results that I didn't quite understand, so I need to investigate that further. But yeah, it's all in a compute shader. So let me just think, am I doing this right? Surface water mass, total water mass, air water mass. Okay. So I believe this number 10 should be the total water mass. See if that compiles. If I had some kind of typo or something. Oh, and it works. Okay. So we're looking at the air water mass. If I look at the surface water mass, you can see that I have a lot of water in the oceans, and then some shallow oceans, and like this is the sort of the border of the island. There's a little bit of water, and then on top there's basically no water. And so it should be pretty similar when I look at total, except maybe there's a little bit of water above the island in the air. Yeah, perfect. And what are some of the cool ones? There's elevation. Drawn heat. I draw some terrain in there. You can see some. Oh, and let me make the paint radius a little bigger. I'm drawing some terrain, and so I don't know if this is kind of like the pseudo color stuff you're talking about, where I have different colors for different ranges of elevations, and you can see sort of the ISO lines, and it's kind of similar for. Just look at pressure. So there's my air pressure for my Pepsi plant. If I zoom in, you can see these ISO lines here. I just sort of shoved a mountain in between there, and that's why that broke that up. And so I got one more, which is the velocity. The simple way to do velocity is just to say, like, the red is your east-west velocity, and your yellow is your, or not yellow, your green is your north-south component of the velocity. It would be cool if I could actually like get some little arrows drawing in there. I think that'll take some more thinking offline to get that going. So let me just quickly do the first one. Display wind velocity, which is something that I still have yet to get working correctly. I was doing a little bit today, and I think I'm pretty close. Maybe tomorrow I will have something cool for that, in terms of like the wind actually being generated properly based on the air pressures. And so, and I store my velocity in like a local polar coordinate system, which makes it easy so that I know that x is east-west and y is north-south. Equals n.air properties 1.zw, I think. Just double check here. Height, temperature, that's land, and then this is water, temperature, water, and velocity. Okay. I think what you're doing is pretty similar to the pseudo color palette. The idea of the palette is just to use a 1D texture with all the colors. Yeah, that is a nice thing to do. And maybe in the future I'll change to that. Yeah, that's a little more flexible way to work with. You do have to generate those textures and then bind them all to a shader. But I think this is good enough for now. Maybe in the future I'll get fancier. But like that kind of thing also works for like color correction on like say you have a game and you want to make it more like a blue for like cool tones, or like yellow, or like whatever kind of emotion you want to get out of the scene, or even just increase or decrease contrast. People often do that kind of stuff where you feed in the colors and then you get different colors as an output. But usually they're a lot closer to the initial inputs than with this kind of stuff. And so I think so it really kind of depends on the range of values I want to represent. But to start off with, I'll just say that O.emission equals So this is a two-dimensional, value, and 0 is 0, and so it can be negative or positive. And what I want to do is make 0 be like a middle gray. Velocity times something. Yeah. Times scale plus 0.5. Scale will be, let's try 1 to start with. Oh, and nothing in the blue. So if I go and I look at wind velocity, oh, I have this pretty cool looking map. And that looks like pretty cool. It's not really changing right now because I still have to work on the wind stuff, but one day that will be really cool looking stuff. Oh yeah, color temperature like that is really cool. And if you don't know the exact temperature of each grid cell in Kelvin, you could use color temperature to figure out what color it would be exactly. So, what I could do with the wind is I was thinking like maybe I can do something where like I have too many verts to like interpolate it. Like say I had like a texture map with a little arrow and I wanted to map that to the surface and somehow pick the UVs based on the wind speed. As it interpolates between those different points, you could get some really wonky results. So I would have to somehow discretize that more easily. I do have this little tool, however, though, where is it, that allows me to inspect individual values. So like I can mouse over and you can see it gives me the exact value of the surface temperature, or the total water mass, whatever it is. And for the velocity I added a little arrow. So yeah. And so, yeah, let me just go through and just quickly show all those different visualizations. So we start off, we got obviously a default, we have a frozen planet here. If I put a little heat, or actually what I'm going to do is make the sun a lot hotter. Let's make it like 70 so it gets really hot. It should melt some of that ice. And it looked like it caused some evaporation from the ice and created a little bit of clouds there for a second. And you can see the green, like that's a life-supporting habitat, but I think it's quickly getting too dry or too hot, and so that life kind of started disappearing right here, but it's appearing down there. And obviously this is like way too fast of a simulation, but for my testing, it's helpful to make it faster. Am I using a cube to store the data on the sphere? No, it's just I store the data for each vertex. Let me go into like a wireframe mode here. So I have these different concentric spheres for the clouds and the atmosphere. But I turn off those, I have just the planet here. So every single vertex that you see has like the simulation data associated with it. And this is just a geodesic sphere that I had it build based on taking an icosahedron and then repeatedly subdividing it. And so one interesting thing about that is if it were just like these aren't, like rectangular cells like you would get, like kind of your probably the standard way you'd think of doing a sphere, which rectangular cells does make, doing some of the simulation a little bit simpler. But I wanted to make sure that I had equal area triangles all over the sphere, so it doesn't matter if you're near the poles or not, you still have, triangles of the same size. And so that was something that I thought was a valuable property. Yeah, so I have neighbor lists for every vertex. So for every vertex, basically in the entire world, there are exactly 12 vertices that have 5 neighbors, but the rest all have 6. And around each vertex, you can imagine a little hexagon. And so when I'm simulating, I'm imagining that the little hexagon that's like a Voronoi region around that vertex is the area that I'm simulating for. So if we go back to our visualizations, so that's the normal look. And yay, we're finally getting a little bit of melting of the sea ice as the sun goes around. Maybe if I make it even just a little bit hotter, we get more, and it's heating that land a lot more than the ice, probably because I need to tweak my my specific heat values, so where it's like kind of almost melting those rocks while it's barely melting the sea. But if we look, because right now I'm in the middle of a transition period where I'm trying to make all the values more real and physically accurate, rather than just a bunch of fudge numbers, using real numbers for the Earth and for physics, like actual black body radiation, that kind of stuff. But with that said, you can look at the elevation, and if I make this taller, you get more elevation change there. And I like to take my brush and make it a little smaller, so I can get cut a nice little canyon here. Put a hole in that. Get some really crazy elevation differences. So that's elevation. Surface temperature. That's pretty cool. You can see the land is a lot hotter than the sea, and there's some sort of transfer of the heat around, and I'm not sure how much of that is just because the sun is going around and how much is because of sort of diffusion between the neighboring cells. Yeah, the ice is almost totally white on this, so that would actually, let's see what I do for, I don't know if I'm considering that right now for the simulation. I am considering albedo, but I think just the land color. It's sort of I have all these components, and I'm refining each of them to get more and more accurate. Albedo. Or RGB factor. Okay, so I have surface absorption, which is basically 1 minus the albedo. And then if I have water, I did consider I should reflect some, specularly reflect some of that off, but I didn't yet make a distinction between the ice and the liquid water. Then how much water is on the surface. Where's total water? You have some in the air here, actually quite a bit in the air there, because it's so hot, I guess it can store a lot of water. The air temperature, which is a bit different from the surface temperature. Air water mass. Wow, now there's a lot over that land. The air pressure is really high in certain areas, and you can see it kind of pushing around. Air gases is similar to air pressure, except it doesn't include the water or smoke, so that's why you saw that big hot spot disappear, because that's apparently all water creating the air pressure there. Relative humidity right at the surface level, and then relative humidity higher up in the air, and so where it gets into the green range should be where it's raining. So if I would actually turn on my clouds, I can see some clouds there. And then total water mass, we already looked at that, and then our wind velocity, which is kind of broken velocity right now, but that's something. So those are the visualizations I wanted to do today. So I think that's all for today's stream. I've got some others. I've got to go out in the world today. So yeah, let me know what you think. Please follow and come back tomorrow when I'm back on at it's 4 p.m. Eastern and 1 p.m. Pacific time, and hopefully I'll have some cool wind and air pressure stuff going on. And this is looking really trippy. I had a really funny accident yesterday where I had some values go way out of like get way too crazy, and like all the water exploded off the planet, and it looked pretty crazy. And I'm trying to remember what it was. Here we go. I'll show the GIF here. Pretty amazing. I could not believe how that looked. And that was a total accident. But yeah, that's it for me for now. See you all later.